Today we're going to be talking about graphing rational functions. Now consider the rational function where we have a polynomial on the top, a polynomial on the bottom. Okay, vertical asymptotes. Make sure you understand this. Make sure you have this written in your notes. This is very, very important. Vertical asymptotes happen for all values when the bottom equals 0. So in the last lesson, those were our restricted values. Okay, so vertical asymptotes happen when the bottom equals 0. Now, our horizontal asymptotes. So we have a horizontal asymptote. Now there's three possibilities. Okay. If P is greater than Q. So if the power on the top is greater than the power on the bottom. So like if I had x to the third over x squared. Okay. That's an oblique asymptote, but we would have to divide to find the asymptote. Okay, so we'd have to divide x minus x squared into x cubed, and I'll do an example of that. If the degree on the top is less than the bottom, so now if those were switched, x squared over x cubed. Think about it. Which number is going to get bigger faster? You're going to have bigger numbers on the bottom. So your end behavior, or your horizontal asymptote, what happens as x gets really, really big, is going to get really, really small because the bottom is going to be a lot bigger than the top. And 1 over a really, really big number is really close to 0. Now if your degrees were equal, so if it was something like 5x over 2x, it would be the line y equals 5 halves. Okay, and that's the leading coefficient of P and the leading coefficient of Q. 5 halves. Okay, graphing rational functions. What I want you guys to be able to find. I want you to be able to find the zeros, the asymptotes, the y-intercept. For your graph, you're going to be allowed to use your calculator. Okay, I'm being nice, letting you guys use your calculator. Zeros, remember, fancy word for 0 is when y equals 0. So I set my function equal to 0. Okay, so when you have a fraction that equals 0, all you have to worry about is the top equaling 0. That's the only time your function's going to equal 0. So that's at x equals 0. So I know one of my points is going to be 0, 0. Asymptote, vertical asymptote, happens when the bottom equals 0. So our vertical asymptote is when x plus 1 equals 0. So that's x equals -1. Horizontal asymptote, or the oblique. Okay, so x to the third x squared, there's no horizontal asymptote. Technically, that's an oblique asymptote. If the power on the top is greater than the power of the bottom by more than 1, so like their difference now is 2, yeah, that's an oblique asymptote, but I'm not going to stress about you guys finding it. So we don't even need to worry about finding that one. So the only one that we're going to have to find is this one. Y-intercept. Y-intercept, remember that's when x equals 0. So I'm finding f of 0 when x equals 0. I have 0 over 0 plus 1, 0 over 1, that's 0. Keep in mind, we found the origin. The origin is when you have an x-intercept and y-intercept. So our y-intercept is also 0, 0. So now to graph that guy. Okay, right now I want you guys to pull out your calculators and graph that function. Remember our function was this. Okay, on our graph, let's draw in our asymptotes. We found one of the vertical asymptotes to be x equals -1. So I draw that in. That's something I want you guys to have drawn in. Now graph this in your calculator. And make sure with your syntax you're typing it in x to the third divided by. Now make sure you're putting the whole denominator in parentheses, or else you're not going to get the right graph. Okay, so how to type the functions into our calculator. So you go to y equals. And then you type in the function x to the third. Now mine might be a little bit different than yours. If yours looks like mine, make sure now you're out of your exponent, divided by. Now in parentheses, make sure you put the whole denominator. So now we have that. So that's the function we're trying to graph. And what I want you guys to do, let's do a zoom 6, a standard window. And you see that's what the function looks like. Now some of you might have a line that's drawing in here. What that's doing is that's connecting this topmost point with that bottommost point. When I was a student, I used to think of that as it was drawing in what the asymptote was for me. Okay, so keep that in mind. So if you see it being connected, you're not going to draw that in. That's the asymptote that you're going to draw in graphing. Okay? We have the point 0, 0. Now, even I don't know what this graph looks like, so I use my calculator to graph. So now from that calculator graph, let's kind of copy that to our grid, and you guys can just give me a sketch. It looks something like that. We had that piece over there, and then we had a piece down here that came down to a certain point and went over like that. Okay? So for this one, you're just giving me a sketch of what the graph looks like. Next example. Okay, zeros. That's when the top equals 0. Okay, or when y equals 0, which means the top equals 0. So 6x equals 0, or x equals 0. So again, I have my origin as one of my zeros. That means that my y-intercept is also 0, 0. The y-intercept, you make x 0. Let's just check and make sure nothing else becomes 0. No, we don't get anything else to be 0, so we have 0 over negative 12, which would end up being 0. So again, our origin is going to be where our 0 is. Now the asymptote. Okay, vertical asymptote happens when x plus 3 equals 0. So that's x equals negative 3. Happens when x minus 4 equals 0. So that's at x equals 4. Horizontal asymptote. What's the degree of the top over the degree of the bottom? The degree of our top is 1. If I were to multiply these two quantities out, the degree of the bottom would be 2. So the top is less than the bottom. So therefore I know then that the top is going to get not as big as the bottom, which means I'm going to have a really small number, which is y equals 0. Now graphing, again in your calculator, our function was this. X plus 3, x minus 4. Make sure in your calculator you're typing in, put 6x all in one parenthesis divided by. You're going to have double parentheses here. One parenthesis for the whole bottom, one parenthesis for x plus 3, close that out, x minus 4, close that out, and close everything out. Okay? So that's how you're going to type that in your calculator. Now graphing the second function. Again, in parentheses, make sure you put 6x, close your parentheses, divided by. Now you need a double parentheses because we had x plus 3 times by x minus 4. Close your parentheses for the x minus 4 and for our whole denominator. Let's do a zoom 6. And that's what our graph looks like. Now again, if you guys have an updated calculator, your graph actually gives you a really good graph like I have drawn in here. If yours is a little bit older, that's okay. What again, you might have a line in there, a line in here, where your asymptotes appear to be. It's your calculator's just connecting this top point with this bottom point. It's just a feature of some of the older calculators. So you don't actually draw that in. What you're going to do is you're going to actually draw in the asymptotes. And again, when I was a student, I used to think that, okay, the calculator's just drawing in the asymptote for me. Okay, I now know where my asymptotes are. Okay? All right, putting in my x's. Okay, now putting in the x's, we can now put in our asymptotes. Our vertical asymptotes were -3, +4. Okay. Your horizontal asymptote was y equals 0. And I'm still drawing that in. Now you have your origin, which crosses your horizontal asymptote, is an intercept. Okay? So I'd expect you to get all of that without your calculator. Now, graph this on your calculator. Now that we've graphed that on our calculator, we got something that looked like this. And again, you're just giving me a sketch. I shouldn't even really have grids in here because they're not really putting even points in. Okay, so you're just giving me a sketch of what the graph looks like. Okay, our next one. And everybody, zeros, asymptotes, y-intercept, and graph. Okay, zeros are again when the top equals 0. So I'm going to factor that now. Okay, so we have a +5 -3. So our zeros are -5 and 3. So make sure you graph those. Those are points now. So this is new. We have -5, 0, and we have 3, 0 that we're going to graph. Asymptotes. When the bottom equals 0 is our vertical asymptote. So that's x equals 1. And make sure you guys realize that that's the equation of a line. So I'm writing x equals. Now the power on the top is bigger than the power on the bottom. So power on the top bigger than power on the bottom. So I have to divide. So I have to divide x minus 1 into that numerator. Let's use synthetic division. So I put a 1 in there. We have a 1, a 2, and a -15. Bring down your 1. 1 times 1, 1. We add them. 3 times 1, that's 3. Remember, this was our remainder. We don't care about the remainder. All we care about is this piece right here. Remember, that reduced the power by 1. So what that means is that becomes our oblique asymptote. So we're going to graph the line x plus 3 as our oblique asymptote. Okay, for our y-intercept, you make x equal to 0. Now when you make x equal to 0, you have 0 squared plus 0 times 2 minus 15 all over 0 minus 1. We get positive 15. What I often do for my y-intercept, I cross off any term that has an x in it because that goes away. So I just look at what negative 15 over negative 1 is, which is a positive 15. So I'm going to graph the point 0, 15. So I would expect you guys to be able to find all of this stuff without your calculator. Now graphing this guy on our calculator. So we had a asymptote of x equals 1. We had an oblique asymptote of y equals x plus 3. So that's the equation of that line. Now we have our zeros. Negative 5, and we had positive 3. And then we had all the way up here at 15. So I look at this like it has dueling corners. Okay, you're never going to cross a vertical asymptote, so you're in opposite corners. You're in like vertical angles if you think back to geometry. We have one curve there, one curve there, and our graphing calculator, if you were to graph that in your calculator, would confirm that. So I'm not going to show you guys graphing that in your calculator, but make sure you're typing in to your calculator correctly, and you should get something that looks like that. Okay, next example. Graphing rational function with a whole. We have a wholly function. Catholic school, we got to have holy functions. Hee 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 hee, Myrna, you're so funny. All right. You know your function has a hole in it when you factor. So you factor the top, and you factor the bottom, and something cancels. We have a whole, ask your English teacher which one's better, when x minus 3 equals 0. So that's when x equals 3. So we have a whole at x equals 3. Okay? Now the new function that you're graphing, is f of x equals x plus 3. Just you have to have a hole in the function. Okay? So the new edited function is x plus 3. That has no asymptotes. A 0, y-intercept is 3. Y equals mx plus b. X-intercept, negative 3. You're just graphing a line. So this is actually a really easy function. Okay, we have a hole at x equals 3. That function is x plus 3. So we don't even need our calculators for this one. Okay, we're going to graph x plus 3. But at the x value of x equals 3, we're going to have a hole. So that's what that function is going to look like. Okay? Hey, that's actually a pretty easy example for you guys. Okay, there are your 3 lesson questions. Please make sure those are submitted on time for me.